Good morning, ma'am. I am Sadiya Anzum from the Department of Computer Science and Engineering from the section E. My topic is state Cauchy's mean value theorem and find C of Cauchy's mean value theorem for the functions f of x is equals to root x and g of x is equals to 1 by root x in the closed interval a comma b where 0 less than a less than b. First of all, what is mean value theorem? The theorem is used to prove statements about a function on an interval starting from local hypothesis about derivatives at points of the interval. The mean value theorem states that if a function f is continuous on the closed interval a comma b and differentiable on the open interval a comma b, then there exists a point c in the interval a comma b such that f dash of c is equal to the function's average rate of change over closed bracket a comma b. There are multiple types of mean value theorems in calculus, including Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem. Let us discuss them one by one. So first, Rolle's theorem, a special case of the mean value theorem that applies to certain conditions. Rolle's theorem was originally proposed in the 17th century and was only proven for polynomials. So this theorem is from the mean value theorem that applies to certain conditions only, and it is only proven for polynomials only. So it is generally proposed or discovered in 17th century. And let's Lagrange's mean value theorem. It is also known as first mean value theorem in the all theorems in calculus. Next is Cauchy's mean value theorem, proposed by Augustin Louis Cauchy in 1823. So overall, the mean value theorem is a fundamental theorem in calculus that establishes the framework for the entire subject. It states that for a curve passing through 2 points, there is a point on the curve where the tangent is parallel to the secant passing through the 2 points. So let us discuss all these theorems individually. Rolle's theorem. This theorem states that if a function f is continuous on the closed bracket a comma b and differentiable on the open interval a comma b such that f of a is equals to f of b, then f dash of c equals to 0 for some x with a less than or equals to x less than or equals to b. So Rolle's theorem states nothing but if we get a function like f of x, it should be continuous on the closed interval a comma b and it should be differentiable on the open interval a comma b, and after that it should prove a condition, it should possess a condition f of a equals to f of b. Then we get a point f dash of x is equals to 0. Then only the function should prove or verify Rolle's theorem. Next, Lagrange's theorem. Lagrange's mean value theorem is one of the most important results in real analysis. It is used to prove statements about a function on an interval based on local hypothesis about derivatives at points on the interval. It is also as somewhat equal to Rolle's theorem, but it doesn't include any condition for verifying like f of a equals to f of b in Rolle's theorem. But it is not present in the Lagrange's theorem. Let us move to our main topic, Cauchy's mean value theorem. Cauchy's mean value theorem is a generalization of Lagrange's mean value theorem. So it is contracted from the Cauchy's mean value theorem that establishes a relationship between the derivatives of two functions and the variation of those functions over a finite interval. In the previous two mean values theorem like Rolle's theorem and Lagrange's theorem, we only use one function, but here we use and show the relationship of the derivatives of the two functions like f of x and g of x. Let us see the statement of Cauchy's mean value theorem. Statement: if a comma b in closed interval assigned to R and g a comma b in closed interval assigned to R such that f of x and g of x are continuous on the closed interval a comma b and f of x and g of x are differentiable on a comma b in open interval. So here also the two functions should be continuous in closed interval and differentiable on the open interval. And then only here we get a condition like g dash of x is not equals to 0. Here we do the derivation of two functions and we check the second function like g of x derivative must should not equal to 0 for all x belongs to a comma b. Then there exists a point c belongs to a comma b such that here we get the problem like f dash of c by g dash of e, c equals to f of b minus f of a by g of b minus g of a. Let us discuss this in briefly. Okay, we get a problem here. Then we will discuss the Cauchy's mean value theorem and understand more briefly with this problem. Find C of Cauchy's mean value theorem for f of x equals to root x and g of x is equals to 1 by 2 root x in the closed interval a comma b where 0 less than a less than b. Let's solve this problem. First of all, we take the two functions given by f of x is equals to root x and g of x is equals to 1 by root x. We do the differentiation of these two functions. F dash of x is equals to 1 by 2 root x. Generally, the differentiation of root x is equals to 1 by 2 root x. And g dash of x is equals to 1 by minus 2 root x. The differentiation of 1 by root x equals to 1 by minus 2 root x. So we check this continuity and differentiability of these two functions. So they are continuous on the closed interval a comma b and they are divariable on the a comma b in open interval. Thus the condition of Cauchy's mean value theorem satisfied, then there exists c belongs to a comma b such that f dash of c by g dash of c equals to f of b minus f of a by g of b minus g of a. So here we have taken the differentiation of two functions like f dash of x and g dash of x. Then we substitute c in the place of x in the both differentiable functions. Then we get f dash of c by g dash of c equals to, we substitute in the main functions a comma b. Then we get f of b minus f of a and g of b minus g of a. After the substitutions, the answer is f dash of c equals to 1 by root x by f g dash of c is equals to minus 1 by 2 root c equals to f of b is root b minus f of a equals to root a by 1 by root b minus 1 by root a. These are the g functions. Here we get we are going to reciprocal the denominator problem in the left side 1 by root c into minus 2 c root c by 1 equals to root b minus root a by, here we are doing LCM. So cross multiplication root a minus root b by root ab. Then we get, here we get minus c. In the previous we get root c are cancelled. Then minus c we get here. Here we do the reciprocal of the denominator problem function. Then it becomes like root b minus root a into root ab by root a minus root b. Next, in the next step, left side we kept c minus c as it is, and in the right side we kept the numerator as it is, root b minus root a into root ab by, we interchange the positions of root a and root b and we get the minus as common. So it becomes minus of root b minus root a. In the next problem, we cancel the denominator and the numerator root b minus root a. We get minus c is equals to minus root ab. Here minus get cancelled. C equals to root ab belongs to, and here root ab value belongs to in between a comma b. Hence the Cauchy's mean value theorem is verified. Thank you, ma'am. Thank you for giving this opportunity.